question is a coil which radius is 30 centimeter has 40 turns. The coil is placed between poles of electromagnetic. The magnetic flux density which pass through the coil change from 0.0 Tesla to 0.5 Tesla in 4 seconds. What's the magnitude of induced electromotive force in the coil if we have two conditions? First one, area vector of 110 of the coil is parallel to the magnetic flux density, while the second order is magnetic flux density vector makes an angle of 30 with the coil plane. وطبعا تعرفون لي حل مثل هذا السؤال. First of all, we should find out the given R 30 centimeter. R 30 centimeter. Number of turns 40. Okay. 0.0 Tesla to 0.5 Tesla. This represents the change in density flux. Okay. Of B. Okay. Equal 0.5 minus 0.0 equal 0.5 Tesla. 4 seconds represents T, time. The order is, what is the magnitude of induced electromotive force? The order is, what's the magnitude of E induced? Now let us begin to solve this equation. To find E induced, we should find at the first the magnitude of phi or delta phi. To find delta phi, we should find out the area of the ring or of the coil. Therefore, we say A equal pi r square, circle, because the coil is a circle. Now, A equal r square 0.3 squared times pi equal 0.09 pi meter square. Okay. Then we should find out the phi or delta phi. Delta phi equal B A cosine theta. B A cosine theta equal delta B is 0.5 Tesla times A 0.09 pi cosine. Now the angle is, as the order says, area vector of one turns vector is parallel to the magnetic flux density. When they parallel, that means the angle is equal to 0. Therefore, we say E equal 0.5 times 0.09 pi cosine 0 1. The resultant is 5 times 10 45 1 2 3 1 2 3 or pi Weber. Let us write it here. 0.45 pi Weber. Now we prepare everything to apply our relationship. Now to find E induced, we should apply the relationship which said E induced equals minus n delta phi over delta t. Faraday law. E induced equals minus n number of turns, 40, times delta phi. Delta phi is 0.045 pi divided by time 4. Now we can simplify between the numerator and denominator like this. 4 equal 1 minus 10. E induced equal minus 0.45 pi, and the unit is volts. In brief, at the first we find out the given are 30 centimeter, and we transform it from centimeter to meter by multiplying it by 10 to the power minus 2. Number of turns, 40 turns. Delta B equal 0.5 minus 0.0 equal 0.5 Tesla, and the time is 4 seconds. The order is E induced equal question mark. And we solve this question by find out at the first the area of the turn as a circle, pi r squared, and the resultant is 0.09 pi meter squared. Then we find out the delta phi, flux density, delta phi, using the relation delta phi equal delta B A cosine theta. Theta was 0 because the area vector of one turns of the coil is parallel to the magnetic flux density. عندنا ملاحظة مهمة. Now you have an important notice. When we find this phrase area vector, a phrase consists of two words, area vector. We take the angle, the same angle in the question. For example, question says theta equals 30. Therefore, we say our angle theta equals 30. While this phrase is absent, for example, the order B, magnetic flux density vector makes an angle 30 with the coil plane. It doesn't say area vector. Therefore, our angle is not 30. Our angle is 90 minus 30 equals 60. Our angle is 60. Now, to solve B branch, magnetic flux density makes an angle 30, we say A, the same A as in A branch. Okay, 0.09 pi meter squared. Then, now we must find delta phi equal delta B A cosine theta equal delta B 0.5 A 0.09 pi times cosine 60. 0.5 times 0.09 pi times 1/2. equal 0.45, okay, pi times 0.5. Now delta phi equal 5 and pi 1 2 3 4 1 2 3 4 pi Weber. Now to تكون واضحة هنا مساحتنا. نعم أشكرك. phi equal 0.0225 pi and the unit is Weber. Now we prepare everything for applying Faraday law. We say E induced equal minus N delta phi over delta T. E induced equal minus 40 delta phi 0.0225 pi over delta T 4. Now we simplify between numerator and denominator, and E induced equal minus 0.225 pi and the unit is volt. Another question says, conductive circular ring with an area of 626 centimeters squared, as resistance 9 ohm is placed on the plane of the paper. The magnetic flux density is 0.15 Tesla perpendicular to the plane of the ring. Then the ring is pulled and reached an area of 26 centimeters squared during the period 0.2 seconds. Calculate the induced current in the ring. Now we should find out the given. 626 centimeters squared area. Okay, the resistance is 9. This is 9 ohm. Okay, the flux density is 0.15 Tesla. B equal 0.15 Tesla perpendicular to the plane. Then the ring is pulled to reach another area, A, 26 centimeter square during 0.2. This is the period of time, T equal 0.2 second. 0.2 second. Okay. Now the order is, what's the magnitude of I induced? To find I induced, at the beginning we should find the E induced, the electromotive force after finding the I induced. Now A, we have two areas, therefore we must say 626 minus 26 equal 600 centimeters square. Delta A equal 600 times 10 to the power minus 4 equal 0.06 meter square. delta A equal 0.06 meters squared. Then we should find out phi, or delta phi, equal delta B A cosine theta, equal delta B 0.15 Tesla, 0.15 Tesla times A 0.06, okay, cosine 0. Delta phi equal 6 times 15, 0, 9, 1, 2, 3, 4, 1, 2, 3, 4. Cosine 0 is 1. Delta phi unit is Weber. Now to find E induced equal Faraday law minus N delta phi over delta T. E induced equal minus the number of turn. It is one ring, conductive circular ring, therefore we substitute 1 times delta phi 0.0090 over delta T. Delta T is 0.2. Equal minus over 2.09 equal minus 1.045 volt. Okay. Now we found E induced. Then we must find I induced. As Ohm law equal E induced over R. I induced equal 0.045 over R equal 9. I induced equal 5.05 ampere. Another question says a 0.1 meter conductor rod moves with a velocity of 2.5 meter per second. The total resistance is 0.03 ohm and the magnetic flux density is 0.6 Tesla. Calculate the amount of E induced, I induced, F pole, P dissipated. Now let us find out the given. L 0.01, the length of the rod. B equal 0.6, the flux density. The velocity of the movement equal 2.5 meter per second. The resistance of the total circuit, the rod and the circuit, equal 0.03 ohm. Now to find E induced, here E induced mean E motional. It's equal VBL. V, the velocity, 2.5 times B, 0.6 times L, 0.1. 630 0.1 1 2 3 1 2 3. E induced or E motional equal 150 volt. This is the first order. The second order, to find I induced, as Ohm law, E induced divided by R. I induced equal E 0.5 over R 0.03 equal 15 over 3. I induced equal 5 ampere. Okay, this is the second order. Third order, to find F pull equal I B L, the current times density of flux and times by L, the length of the rod. F pull equal I 5 times B 0.6 Tesla times L 0.1. 0.30 Newton. Now, the fourth order, the power that dissipated in the resistance, P dissipated equal I squared times R. P dissipated equal I 5 squared times R 0.03 equal 25 times 0.03 equal 3 7 1 2. The unit is watt. أعتقد السؤال سهل.